Howdy everybody. In this video I want to show you how to loop through a bunch of classification models and a bunch of regression models. I'll show you the very primitive classical way of doing this, and then a much more modern, streamlined, automated way of doing this. So I think we can just jump right into it. So I've got classification data right here. This is the canonical iris data set where X variable is the independence and Y is the dependence. I'm not going to get into too much detail here. I have several videos that explain how all the variables work, the independent and the dependent, and how they interact with each other. So I'm pulling some libraries. I go ahead and do a train test split. Test size is 0.2, so training size is 0.8. Okay, we have the training, testing for the independent variables, training, testing for dependent variable. Is one dependent variable. Okay, I'm going to go ahead and run a Gaussian naive Bayes classifier and check out the results from that. I'm going to do the multinomial naive Bayes. So there's another model. Bernoulli, naive Bayes. Okay, a bunch of classifiers. There's all kinds of random forest classifiers and so on and so forth. There. This is just a small sample. There's probably about I think about 40 or so in the scikit world. 40 regressors and 40 classifiers. So here's a handful just to illustrate the point of how this works. I have one listed after the other. Control Enter to run the code, and we get the output down here. We have the precision, recall, and accuracy score. In short, the higher the numbers, the better. 1.0 is perfect, and accuracy is off by a little bit down here, but that's okay. But we have almost, or basically perfect precision, recall, and F1 score. Okay, an accuracy of 0.73, you see that right here. So accuracy is down a little bit. I have other videos where I get into more about the details of accuracy, precision, recall, F1 scores. I'm not going to dive too deep into it here because it's covered in another video. I'm just showing you how to loop through different models at this point. So that's pretty nice. You can go through a bunch of models pretty quick. It took a couple seconds. The only thing here is that it's a little bit cumbersome to set up and to maintain this block of code. You have to make sure you have no mistakes in here. If there's a mistake, it takes a while to go through and debug it. So that is a primitive way it works, but there is a more sophisticated, more, I would say more refined way of doing essentially the same thing. So here we have all of our classification models listed out. When I say all, I don't mean every single one. I mean, we have a bunch of them listed here. And again, we have the X and Y variables, okay, the train and the test, and now we have our classifiers in a list. So it's very tight, crisp. It's organized very well in this list. If there's any issue, we can go into this list and pretty much figure out what the issue is pretty quickly and pretty easily, debug it, and we're back in business. So I think this is a slightly better way of doing it. Then we're going to go ahead and loop through all the items in these classifiers and call each model as we go. So if I do Control F and look for classifier, here's the loop right here. It's for CLF, that's short for classifier. In classifiers, that's the list. I'm going to do the train test, and then the prediction is right here. CLF predict, and then I'm going to go ahead and calculate the accuracy, precision, and recall, and plot the results. So I think this is a more sophisticated way of doing what we saw in the previous step. I think this is easier to set up and to maintain because you don't have to create all kinds of separate and distinct code for all models. You just have to put all the models into one list and then iterate over the list, right? So let's see, here's the printout. So that looks nice. Let's look at the data frame right at the end. Everything is nice, organized, easy to read, easy to understand, okay? Laid out pretty decent there. So we could take that to our client and to our stakeholder and do a quick demo and explain what's going on, and the message should get communicated pretty quickly and easily. And then I create a chart too, so you can see how each classification model performs relative to the others. In this case, I'm looking at the accuracy metric, and we have from 87 down to about 69, right? So in this case, the gradient boosting classifier really performed the best. I'm going to do this again on the regression side. So now we're looping through a bunch of regression models. Okay, same concept. We store all the models in a list. We go ahead and loop through each element of the list. and we can see that right here for REG. That's the variable. These are the items in the list for REG and regressors. Go ahead and calculate the RMSE, the MAE, mean absolute error, and the R squared. So again, we get a nice printout down here, and of course the data frame, and then we have the plot down here, so we can check out all of the details of each random forest, not random forest, of each regression model. So the top R squared is 0.73, so we would probably pick that. Although we might test more. There's only about, was there 9 or 10 models here, and there's about 40 in the whole universe. So that brings me to the next step. So that's all well and good. You have to know some coding. You have to understand how to set up the models, train, test, so on and so forth, and interpret the results. There's a library in Python called LazyPredict, where you can literally just feed in your data set, and it's going to generate all of these results for you, all the RMSE, MAE, R squared, without coding hardly anything. So this is called a low-code solution. There's a lot of code in here. If you're comfortable with it, that's fine. If you're not comfortable with it, you might prefer a low-code solution. Okay, there's still some coding, but it's only maybe 15 or so lines of code, and some of this is just very simple print statements. Some of it is training and testing, independent dependence. We have that from before. We were pulling in the mtcars data set. If you saw most of my other videos or any of them, you'll see that I use mtcars quite often. I like it a lot, and it's very easy and intuitive to work with. So what are we looking at here? Basically, the library called import LazyRegressor, okay, from LazyPredict, and then we initialize and fit the regressor, and that is literally it. So it's probably like one line of code that you have to learn here. This LazyRegressor produces this reg variable, and this regressor fits these models, right? So that is pretty cool, with literally like 2 lines of code, importing the library and then calling the library. Control Enter to run it. And let's see what we get here. Okay, it's running. It takes a few seconds. But honestly, with 2 lines of code, literally, and we're just repeating what we did above with the training and the testing. These are warning messages, nothing to be concerned about. No errors per se, just warnings. And now we see all of the regression models, and there's probably about 40 or so listed here. So much more comprehensive than the list I was working with before. And we see a nice, nicely produced chart here. So we have the adjusted R squared, RMSE, and then the time it took to train and test each model. So if we look here, these R squareds are horrible. We don't want to see negatives. We want to see at least high 0.7s, probably 0.8. So these are getting better down here. This is getting better and better, up to 0.89, right? So 0.89, in a couple of seconds, we got the best model of all the models available to us for doing regression, extra tree regressor, 0.89. So that one really performs quite well. Low RMSE and high R squared, 0.1 or 1.0 would be the best. 0.89 is pretty close to 1.0. So let me go down here and see what else. Okay, so we got the same thing. Extra tree regressor, that's the best model in the whole list here. Okay, if I copy this, I'm just curious. I wonder how many. I think it's about 40, give or take. Let me put this in Excel and count it real quick. Bear with me. So we get that model. Okay, I think we can cut off there. Copy, paste. No, we don't have to do this. I'm just curious to see how many models it's given us to work with. Pretty comprehensive, I know that. So go up here, paste. And it looks like control down 42. Okay, so 42 models. So that's pretty comprehensive. We have everything literally in the world of regression. So let's do one more example. As you might expect, LazyPredict has a LazyClassifier. It's going to do almost exactly what the LazyRegressor does, except we're working with classification data, which is labeled data, right? So non-continuous, non-numeric data. This is the classic or canonical line data set. Again, set up just like before. 1 line of code, literally run it. Control Enter to refresh. And let's see what the output looks like. It's running. We've got a status bar or progress bar. I guess it's called progress bar. It's chugging along. Okay. We have a couple warning messages. Nothing to be concerned about. No errors. It's just notifying us of what is transpiring here. Okay. Just like before, we get the goods down here, and here we go. So here's the final output with just a couple of lines of code. We can run through all the models and get the accuracy for each one. So this is 0.70 for LGBM classifier. A little bit low. I'd like to see the F1 closer to 1. And the RAOAUC area under the curve, that has actually come up as none. Usually those are populated. That's interesting. But we have the accuracies here, 0.7, 0.69. It goes down and decreases in order down to pretty low numbers, 0.41. That's kind of useless, so we're not going to pick that up. So in this given data set, we would most likely go with the best model here, LGBM classifier. And to get this accuracy higher, we want to see that close to 1.0. We can play around with the hyperparameters. We can find a larger data set, deeper data set, more data to train the model over. The data may be just too sparse to really be able to learn and to make good predictions. The data set isn't huge, I know that, but there's several things we can do to boost the performance of the learner and to increase the accuracy, the prediction capabilities, and the precision of the model, and of course increase the F1 score as we go. So that's it. I just wanted to take you through different ways to loop through different models. I think the LazyPredict is the best one. I would definitely recommend that as a tool for your data science toolbox or machine learning toolbox. Okay, so that's pretty much it. Hopefully you guys learned something new today. Thank you so much for your time and have a great day. Bye.